Hey everyone, today we're going to do our review over the first half of our circles unit, and tomorrow we have a test over this. So first question, find your circumference and area of the circle. So for circumference, there was two different formulas we learned. Either you can do 2 times pi times r, or you can do diameter times pi. So whichever one just ends up being easier for a certain problem. When we look at this problem, see how this chord goes all the way across the circle and it's going through the center? That makes it the diameter. So I think it's going to be easier to use that formula, diameter times pi. But first we need to actually find out what the diameter is. This right here is a right triangle. So we're going to use Pythagorean theorem, a squared plus b squared equals c squared, to figure out that diameter. So 5 squared plus 12 squared equals d squared. Now I don't want d to be squared, I want it to just be normal. So we're going to square root both sides. And then now all I'm going to do is pop all of that into the calculator. So square root of 5 squared plus 12 squared. And I get 13. Okay, so I know that my diameter is 13. But now to find the circumference, all I would have to do is get the diameter and multiply it by pi. So the circumference would just equal 13 pi. And that's it. That's the exact circumference. If it says something about approximation, then you would type it into the calculator and get a decimal, but we could leave it alone for here. And then as for area, we haven't done that yet, so I'm not going to do that part. Okay, the next one, same thing. They want us to find the circumference. So either we would need to know the diameter or the radius. So center of the circle would be about right here. It would be nice to know either the radius, so halfway, or maybe the diameter all the way across. So that circumscribed square, see how it has a side length of 9? So if we were to just get that and move it up, that's also the diameter of that circle. So same formula as before. We can do circumference equals diameter times pi. So that means that the circumference is just 9 pi. Okay, next one. They're going to want us to find some arc lengths and some angle measures. So see how this one says measure of arc ST? That means that it's going to be degrees. Whatever we find out for it, it's going to be measured in degrees. So first what I'm going to do is highlight that arc. So ST, here's S and here's T. So they want to know how long that arc is. As long as the angle is touching the center, so you see how that's a central angle, it's just going to be the exact same. So if the angle is 146, then the arc is also 146. Now to find the measure of angle SWT, SWT is this angle, just following the letters, right? This one is not a central angle because it's touching the edge. Instead, what this is, I'm going to put an arrow pointing to it, is an inscribed angle. And an inscribed angle is always half of the arc that it's touching. So it turns out that it's touching that same arc, the 146. So to find this one, it would just be half of 146, which is 73 degrees. Okay, next one. So same thing, they want us to find two measures. So the measure of YZ, so YZ is this part right here. So let's take a look at what we have. If I knew what this angle was, I could double it, but I don't know that angle yet. So instead, we're going to have to use that we know the entire circle is 360. So to find this part, we're just going to subtract the two pieces that we already have. So I'm going to write it at the bottom. The measure of YZ is equal to 360 minus 160 and minus 130. So 160 because of this piece and 130 because of that piece. And when I do that subtraction, I get 70. So the measure of arc YZ is 70. I'm even going to write it right here next to it so we can see. Okay, then they want me to find the measure of angle YXZ. So if you follow those letters, YXZ, that is this angle here. And that is an inscribed angle. So the center would have been here. So see how it's not touching the center? Inscribed angles are always half of the arc length. So to find that, we would do 1/2 of 70, which gives me 35 degrees. This part right here is 35. Okay, next problem. Now we have an inscribed quadrilateral. The good thing about inscribed quadrilaterals is opposite angles are supplementary. So you see how they want us to find the value of x. Well, x is right here in my diagram, and it is across from angle A. So those two together need to equal 180. So 180 minus 87 gives me 93. So x must be 93. Then to find y is up here. Again, opposite angles are supplementary. So see how these are opposite from each other? So 180 minus 136 gives me 44. Okay, now they also want the measure of arc ABC. So see how it's 3 letters? So that's a major arc. That means that it's going to be more than half the circle. A, B, C. Okay, so if you look at angle D, see how that arc is inside of that angle? And this is an inscribed angle. So to find this arc, we're going to times it by 2. So 136 times 2 gives me 272. Okay, next one. Okay, we're going to do a little bit of algebra here. So they want us to find x and y. So to find x, part of here, this is a central angle. So I'm going to highlight this. This part right here, it's touching the center, so it's a central angle. And central angles are equal to the arc. So that means that the 5x minus 20 has to equal 100. Let's add 20 to both sides. So 5x equals 120. And then divide by 5. X equals 24. Okay, now to find y. Y is here, and that's labeling the arc that's not there. So we knew that this part was 100 because it was touching. How much is the green part going to be? So first I would do 360 minus 100. That gets me 260. So this right here, that has to equal 260. 8y plus 20 equals 260. Let's subtract our 20. So 8y equals 240. Divide by 8. So y equals 30. Okay, turn to the back. Next problem, each one of these little expressions here is referring to the arc that it's next to. So this 3x plus 12 represents this arc. This x plus 25 represents this one. And then 3x minus 27 equals this bottom one. So see how all together it's going all the way around the circle? That means that when I add them up, so all three of them, 3x plus 12 plus x plus 25 plus 3x minus 27, it needs to equal 360. So I'm going to combine all the x's, so that makes 7x, and then combine all the ones that don't have an x, so that's 12 plus 25 minus 27 gives me 10. Still needs to equal 360. Subtract 10 from both sides. So 7x equals 350. Divide by 7. And I'm going to write this to the side. X has to equal 50. Okay, so that's what they were asking for. Okay, this next one. The 3x minus 5, that's representing this inscribed angle here. Like this little piece. The 5x plus 12 represents this arc length. So this angle is an inscribed angle again, inscribed. So they're not just equal anymore. The angle is always half of the arc. Or you could even do 2 times the angle equals the arc. So that's what I'm going to do. I'd rather multiply by a whole number. So 2 times the angle equals the arc. Okay, so we're going to solve this by, let's do distribution first. So that gives me 6x minus 10. Other side stays the same. I'm going to subtract 5x from both sides. So x minus 10 equals 12. And then we're going to add 10. So x equals 22. Next one, in circle S, find the measure of arc DF and the measure of angle DEF. Okay, so starting with that arc, DF, all the way around the circle needs to be 360. So to find this, we're just going to subtract the 2 that we already have. So 360 minus 151 minus 125. So I'm subtracting those 2. And that gets me 84. So the measure of this arc is 84. But now to find angle DEF, which is this angle here, that's another inscribed angle. So it's going to be half of the arc, which gives me 42. Okay, next one, in circle J, find the value of x and the measure of AB. Okay, so we have a chord here. See how it's going from edge to edge? But then it's being intersected by a diameter. See how it's going through the circle? That makes it perpendicular, but it also means that everything got cut exactly in half. So this half of the chord is equal to that half of the chord. And then this half of the arc is equal to this half of the arc. So we're going to set those 2 things equal to each other. Then we're going to solve for x. So I'm going to subtract 4x from both sides. That gives me 2x minus 8 equals 18. Then add 8. 2x equals 26. Then divide by 2. So x has to be 13. Okay, but now to find the measure of AB, they want all the way across AB. So what I'm going to do is I'm just going to plug it into this half. So if I were to plug in a 13 here, 6 times 13, and then minus 8 gives me 70. Well, I know that both sides are the same, so this has to also be 70. So the measure of AB has to be 140 because it's both of them together. Okay, and then this last one. So be careful with how they word things. Anytime you have measure like this, all of these have to be degrees. But then this one says arc length. So those are going to be measured a different way. So let's start with these on the left side first. Start with the measure of arc BC. So BC is right here. So to find that arc, let's see what we can do. Okay, so this is the center. DB is a radius or diameter. So this half is 180. So in order to find this, we're going to do 180 minus 91 to find that. Okay, and that gives me 89. So I'm going to write it here too. Okay, now for AD. AD is this part. We can do the same thing. So this is a diameter. This half has to equal 180. So we're going to do 180 minus 35. And that gives me 145. Okay, now the measure of AOC. So this is a central angle because it is touching the center. AOC, central. So it's just going to be the sum of these two pieces. So 35 plus 89. And that gives me 124. Okay, so now for arc length. Arc length, it's like circumference. It's just that they only want this piece of it. So for this one right here, the length of AB, they want to know how long this piece is. So it's kind of hard to see because it's squeezed in with all the numbers. But we have this 5 here. We know that our radius is 5. So to find AB, I'm just going to write it here at the bottom so I can have some space. We have 35 degrees out of the possible 360, but we're going to multiply by 2 pi r, which is 5. So just type that in all together into the calculator. So it was 35 divided by 360. Okay, and I am getting 3.05, so I'm going to put 3.1. Okay, and then for AC, so AC is this part. So for AC, it's the 35 and the 89. So I'm going to do 35 plus 89. So the measure of arc AC is 124. But if I want to find its length, we're going to do 124 out of 360. And then again, times 2 pi r. And that gives me 10.82, which is just going to round to 10.8. Okay, and that is the whole review, guys. Make sure that you have everything filled in your review, because when you take the test tomorrow, you're allowed to use all of your notes, but especially this review, and it'll help you a lot.